Complete the following expression for the area so that it describes a perfect square. Sketch the area model, then write two equivalent expressions for the area of the square. I'll begin by sketching x squared, a squared with width x and length x. In order to preserve the square, I'm going to use the remaining 8x and distribute them evenly among the width and the length. For example, if I use one value here, if I add one value to the width, I have to add one value to the length so that it remains a square. I'm going to do this 3 more times. And now I've used up my 8x's. 1, 2, 3, 4, and then 5, 6, 7, 8. Again, I distribute the 8x evenly so that I would have the same width and the same length. To finish the sketch of this area model, I need to fill in this gap, and I'm going to do it by using units. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16 units. Now that the area model is complete, we're going to express it as a trinomial and then as a binomial. The trinomial, notice that it's the same thing as this. Well, the beginning is going to be the same, x squared plus 8x, reminding you that the x squared is the big square that we first sketched, and then the 8x is made up of the lengths that I used to match the width with the length. The only thing we added were these 16 units to complete the square. So by adding 16, we now have what is the perfect square trinomial. To get the binomial, we're going to obtain it by getting the width and then multiplying it by the length. Our width is x plus 4. The length is the same thing. It's going to be x, and then we're going to add 4 units. And to get the area of this new perfect square, we can multiply the width with the length. So that's going to be x plus 4 multiplied with x plus 4, which can be rewritten as x plus 4 quantity squared.